Welcome to the DIY Honda Garage channel. Welcome to today's presentation on troubleshooting DTC P0171, which stands for Fuel System Too Lean. This diagnostic trouble code is particularly relevant for Honda Accord models from 2012 to 2017. Understanding this error involves looking into the fuel system's efficiency, particularly how the engine is using fuel under various conditions. The lean designation means there is not enough fuel in the air-fuel mixture, leading to suboptimal engine performance. This issue could affect several components, including injectors, sensors, and the overall fuel supply system. Remember, before beginning any troubleshooting procedure, it is crucial to document freeze data and onboard snapshots for accurate diagnosis. In this sixth step, the focus shifts to the positive crankcase ventilation (PCV) system. Keep the engine idling and pinch the PCV vacuum hose to evaluate its integrity. Meanwhile, use the Honda Diagnostic software, HDS, to observe the AF/FB readings with the vacuum hose pinched. If the AF/FB stays above 1.33, the PCV system is functioning correctly. However, if it drops, it indicates a leak in the PCV system. Any detected leaks in the vacuum hoses must be repaired before continuing. After confirming the PCV system is intact, proceed to the next step of checking the MAF sensor's performance. For the seventh troubleshooting step, start the engine and hold it at 3,000 RPM until the radiator fan engages. It is essential to ensure the engine coolant temperature, ECT sensor 1, is above 158 degrees Fahrenheit, 70 degrees Celsius, during this process for proper readings. Ensure that the automatic transmission is set to park, P, or neutral, and all electrical loads are turned off for accurate data capture, while maintaining the engine speed at 2,500 RPM. Check the MAF sensor readings with HDS. The acceptable range for the MAF sensor reading varies based on the type of transmission. For automatic, it should be between 6.5 and 9.1 grams per second. And for manual, the range is 5.5 to 7.7 grams per second. If the current readings don't align with these thresholds, inspect the air cleaner assembly for damage and replace the MAF IAT sensor if necessary. During the eighth step, monitoring fuel pressure is imperative. Check that the fuel pressure falls between 390 to 440 kPa, approximately 57 to 64 psi, while AF/FB is reading 1.33 or higher. If the fuel pressure meets the adequate levels, it indicates that the fuel delivery system is functioning correctly. However, if it falls outside this range, a problem exists with the fuel tank unit, necessitating replacement. It is crucial to ensure that this low-pressure fuel line operates correctly, as any inconsistencies here will directly affect engine performance, leading to the P0171 code being triggered. If fuel pressure is acceptable, the procedure can continue on to high-pressure tests. The ninth troubleshooting step involves checking high fuel pressure. First, turn the ignition to the on position without starting the engine, and clear any stored DTCs using HDS. After that, start the engine and hold the speed at 3,000 RPM without any load until the radiator fan engages, then revert to idle. Select the DI fuel pressure test from the HDS menu to determine if the high pressure side is functioning correctly. The indications from HDS should show normal ranges. If not, you will need to follow through with the DTC P0087 and DTC P0088 troubleshooting procedures. Confirming the normal range of high-pressure fuel is essential before proceeding to the next steps. In the 10th step, if the lean condition has developed shortly after refueling, It could signify a fuel-related issue. Turn off the ignition and drain the fuel tank, replacing it with known good fuel. After refilling, start the engine and operate the vehicle under previously noted conditions to see if the AFFB remains high. Pay attention to any variations. Documenting your observations is critical for further analysis. If the AFFB readings decrease to an acceptable level, this confirms that the fuel was the cause of the lean condition. If not, you will need to continue troubleshooting to find the source of the issue. For troubleshooting step 11, the focus shifts to the intake manifold for possible vacuum leaks. Disconnect the intake air duct from the air cleaner housing and use the OTC Leakwaster evaporative emission system tester to inject smoke into the intake manifold. If you don't have the appropriate adapter cone, you can also remove the brake booster vacuum hose and inject smoke into that as a workaround. Carefully inspect the intake manifold, throttle body, air intake ducting, and any vacuum or air hoses for signs of leaks. Any detected air leaks will severely impact fuel efficiency and should be promptly rectified. If there are no leaks discovered, proceed to the final troubleshooting steps. In this 12th step, if previous diagnostics have not resolved the leak condition, it may be necessary to replace the fuel injectors with known good units. Turn the ignition to off, then proceed with the replacement process. Start the engine and operate the vehicle under the same conditions that generated the previous high AFFB values to test its new readings. Continuous monitoring is crucial here. Check to see if the AFFB remains elevated despite the new injectors. Should performance improve and readings return to normal, it indicates the original injectors were indeed faulty. If abnormal readings persist, proceed to the next troubleshooting step for a deeper component inspection. Finally, in the 13th troubleshooting step, if the previous actions have not resolved the issue, it's time to replace the AF sensor, sensor 1, with a known good unit. After making the replacement, start the engine and operate the vehicle under previously noted conditions. It is vital to monitor the AFFB readings to confirm whether they have improved or remain at elevated levels. If the situation hasn't changed, a further investigation into the powertrain control module, PCM, may be necessary, and possibly its replacement. The goal is to eliminate any possibilities of faulty readings that could indicate an issue with the engine performance. In this stage of the troubleshooting protocol, it's vital to verify all repairs made. Turn the ignition to the on position and reset the powertrain control module, PCM, with the HDS. Conduct the idle learn procedure to establish the new settings. After resetting, start the engine and hold it at 3,000 RPM until the radiator fan comes on, allowing it to idle down afterward. Check the short-term fuel trim using HDS to confirm that AFFB readings have stabilized within normal parameters. This process ensures that the repairs made have effectively addressed the issues contributing to DTC P0171. If issues persist, refer back through the diagnostic procedures for further investigation. Preventive maintenance is key to minimizing the occurrence of DTC P0171 in the future. Regular inspections of critical sensors engaged in fuel management help identify potential issues before they escalate. Always using high-quality, clean fuel assists in maintaining optimal fuel system health. Poor quality fuel can lead to various engine performance issues. Additionally, monitoring the overall health of the intake system, including vacuum hoses and connectors, prevents unmetered airflow that can contribute to lean conditions. Fostering these maintenance habits not only prolongs the lifespan of components, but also ensures consistent engine performance over time. DTC P0171 impacts the efficiency of the fuel system. which plays a vital role in the overall operation of the engine. Key components involved include the mass airflow (MAF) sensor and air-fuel (AF) sensors that monitor the mixture entering the engine. These sensors are primarily located in the engine bay area, near the intake manifold. Their primary role is to ensure that the correct ratio of fuel and air is maintained for optimal combustion. If these components malfunction, the engine may run lean, risking potential damage or decreased performance. It's crucial to understand where these sensors are situated, as proper diagnostic procedures also depend on their accessibility and condition. To summarize our discussion on DTC P0171, thorough diagnostics and checks are essential in addressing fuel system-related errors. Effective use of diagnostic tools, such as the Honda Diagnostic System (HDS), allows for accurate measurement of critical parameters required for troubleshooting. The significance of identifying and rectifying issues early cannot be overlooked, as unresolved problems can lead to lasting engine damage or decreased performance. Furthermore, proactive maintenance strategies can avert the recurrence of DTC P0171 in the future. Remember, a well-maintained vehicle not only operates efficiently, but also provides peace of mind to its driver. Several issues could lead to DTC P0171. Debris in the MAF sensor is a common cause, as it can obstruct airflow and contribute to inaccurate readings. A leaky brake booster can compromise the vacuum needed for proper fuel operation, causing a lean mixture. Additionally, a faulty positive crankcase ventilation (PCV) system can allow unmetered air into the intake, further exacerbating the lean condition. Lastly, incorrect fuel pressure can inhibit fuel delivery, resulting in insufficient fuel for combustion. Each of these issues requires precise inspection and testing to confirm if they are the underlying cause of the lean condition indicated by DTC P0171. When experiencing DTC P0171, drivers may note several symptoms. Engine misfires are common as the combustion process becomes erratic due to an insufficient fuel supply. Poor acceleration is another significant symptom. The vehicle may struggle to gain speed, making driving frustrating. Moreover, you might observe an increase in fuel consumption, as the engine may compensate for the lean condition by running richer at times. Identifying these symptoms early can help prevent more severe engine damage, so it's essential to address them promptly. Keep an eye on dashboard warning lights, as they may also trigger when this DTC is present. The first step in troubleshooting DTC P0171 is problem verification. Begin by starting the engine and allowing it to idle without load. Make sure the automatic transmission is in park, P, or neutral, N, or for manual transmission, in neutral. Using Honda's diagnostic software, HDS, check the short-term fuel trim, AFFB parameters. If AFFB is greater than 1.33, this indicates that the fuel trim is too high at idle, signaling a potential problem with the fuel system, and you should proceed to step 3 in the troubleshooting guide. If not, follow the instructions to evaluate conditions based on the onboard snapshot. In this second troubleshooting step, you'll need to review the onboard snapshot when the AFFB was highest. Record critical parameters like engine speed, vehicle speed, relative throttle position, REL-TP, sensor data, and accelerator pedal position, APP, sensor data. These parameters will give a baseline of how the vehicle was performing under the conditions of the fault. Drive the vehicle under these previously noted conditions to monitor if there are any changes in the fuel trim. Use the Honda Diagnostic software, HDS, while driving to confirm whether AFFB remains above the threshold of 1.33. If so, Move to the third troubleshooting step to investigate further. For the third troubleshooting step, you'll need to turn the ignition to the off position and remove the MAF sensor combined with the intake air temperature IAT sensor. Inspect this sensor for any debris like lint or bugs that could affect its performance. A clean sensor is critical for accurate airflow calculations. So, if debris is found, it should be carefully removed. After cleaning, use a vacuum to clear any remaining debris from the air cleaner housing. If no debris is detected, reinstall both sensors and proceed to inspect for disconnected or damaged components as detailed in the next step. In this fourth step, a thorough visual inspection is required. Check each of the listed components: the crankcase breather hose, air cleaner housing, intake air duct, oil cap, and dipstick. It's crucial to examine these for any signs of disconnection, leaks, or cracks that could introduce unmetered air into the fuel system. If you find any damaged or disconnected components, make the necessary repairs quickly. This is essential because any air leaks will affect how the engine interprets fuel needs, thus sustaining the lean condition indicated by DTC P0171. Only after confirming all components are secure should you proceed to the next troubleshooting step. The fifth troubleshooting step involves investigating the brake booster system. Start the engine and allow it to idle. At this time, pinch the brake booster vacuum hose that connects to the intake manifold. This will help you determine if there are leaks within the brake booster system itself. Use the Honda Diagnostic software, HDS, to check the AFFB readings while the vacuum hose is pinched. If the AFFB remains above 1.33, that implies the brake booster is not leaking. If it falls below, a leak is present, warranting further inspection of the brake booster vacuum hoses. Repair any leaks found, or, if necessary, replace the brake booster itself, then continue troubleshooting. Please like and subscribe to the channel. See you next time!